We will now discuss how to design a data network. In previous videos, we outlined devices that are used to control data flow. A multiplexer allows the user to select one incoming channel for the transmission of data. A demultiplexer permits the selection of an outgoing data channel. A register stores data and provides shift and load functions for the handling of serial and parallel transmission. The register that we will use contains separate active high, load, and shift inputs. In practice, we will only include the function that is needed in each instance. We will now consider how these devices are used in a specific example of controlled data flow. We rejoin our friends for, phi, and fare. For communication, for can only transmit data in a serial format, whereas phi and fare can only receive data in a parallel format. Our three friends are planning a day at the beach. For has his car and must very carefully communicate to each of the other two whom he will be picking up and where he will meet them. For communicates this information as a series of bits. From these bits, phi and fare must each receive two parallel bits, exactly as shown. Phi and fare must now decode the information that they are given. We are required to set up a data network to make this possible. For the purpose of this design, we will label for as the data source A, and phi and fare as the destinations x and y. We will begin with a tree diagram. We will make the source a 4-bit register with serial output. Each destination will be a 2-bit register with parallel data inputs. The goal is to design a data network that will successfully transmit the 4 bits stored in the source to the 2 destinations. The role of the network is twofold. We must first convert the transmission from serial to parallel format. We must then channel the data to the required destination. The required devices are as follows. The source requires a serial out shift register. Each destination requires a parallel in load register. The serial in parallel out data converter must be a shift register to permit serial input. We will label the converter C. Note that all the registers are synchronized using a common clock signal. Finally, we need a 2-bit 2-channel demultiplexer for data channeling. The demultiplexer is an asynchronous device and therefore does not require a clock signal. Altogether, this is the data circuit. In the next video, we will figure out the correct sequence of steps to perform the required communication.